Hello everyone, welcome to the lesson on lists. This lesson is part of the course Python for Beginners. In this lesson, we will discuss how to use lists to store and manipulate a collection of values. This is the color coding we will be using throughout this lesson. Please take a moment and have a look. This lesson is structured as follows. First, we will introduce the idea of a collection of values and how lists can be used to handle them. Next, we will discuss in detail how to access and update a list. Under updating a list, we will talk about append, modify, and delete operations. After that, we will look at multidimensional lists and some common list operations. Finally, we will conclude this lesson with indexing and slicing. Further, throughout this lesson, we will go through several examples and practice exercises that will help you understand the concepts well. In the previous lessons, you have learned about the text and numeric data types. We use the string data type to store text, and numeric values can be stored using the integer, float, and complex data types. Here are two examples. The string Rohan is stored in the variable name, and the number 20 is stored in the variable age. If we take a closer look at it, we only know how to store a single value per variable. An important question you have to ask at this point is, what if we need to store more than one value per variable? Please pause the video and take a moment to think about it. Before answering that question, is there an actual need to store many values in a variable? Let's take an example. Suppose you need to roll a dice n times and store the obtained values. Again, pause the video and take a moment to think how you can do that. A simple and straightforward approach is to use one variable per value of a roll. As shown here, you roll the dice once and store its value in the variable roll1. You roll the dice again, and you store its value in the variable roll2. You follow this pattern until the last roll. Now, do you see any problem with this approach? As many of you have guessed correctly, there are indeed several problems. First, what if you do not know the value of n beforehand? Let's say you develop a program where users can store the things they buy in a supermarket. One day they might buy 10 things, and another day they might buy 100 things. Hence, we cannot decide how many variables we need in advance. Second, what if the value of n is very large, say n is equal to 10,000? Creating and managing 10,000 variables is a difficult task. So, what is the solution to these problems? The solution is to use container data types. Container data types allow us to store more than one value in a variable. If we go back to our rolling dice example, using container data types, we can store all the n values in a single variable as shown in the diagram. We will learn how to do that in a moment. Python supports many container data types. Some of them are list, tuple, range, and set. Please note that there are many more. In this lesson, we will direct our focus towards lists. Let me start the discussion on list by introducing the basic structure of a list. A list holds comma-separated values between square brackets. Here is an example of a list in Python, which contains 4 numbers, 1, 2, 3, and 4. As you can see clearly, the values are comma-separated and are within square brackets. One important property of lists in Python is that the values within a list need not be of the same data type. To get a better understanding, let us look at a few examples. List 1 contains a collection of numbers. List 2 contains a collection of strings. List 3, on the other hand, contains strings, an integer, and a floating point number, which are all different data types. In the last few slides, we looked at the basic structure of a list and how to create lists. Now, the next step is to learn how to access the values in a list that you have created. To understand things easily, let us take a real-world example. Assume that you go to a library and you want to borrow a specific book on Python programming. The library has books organized on shelves. You find the book you need, which is the second one as shown in the diagram. When the librarian asks, which book do you need, what would you say? You can say, I need the second book on this shelf. But the librarian wouldn't know whether you are referring to the second book from the left or the second book from the right. Therefore, you have to say, I need the second book from left on this shelf. Accessing the values in a list works in a similar manner. Here, we have a list with some numbers. If you want to access a number, you have to specify the location of the number in the list. The standard term for location in a list is index. Look at how the numbers are indexed in the diagram. If you want to access the value 96, you can say, I want to access the value at index 2 in this list. One important point to note is that the first index is not 1, but 0, and the indexes are considered from left to right. Therefore, the value 15 is at index 0, the value 20 is at index 1, and value 17 is at index 4. The standard way to access a value at a specific index is to call the name of the list, values in this example, followed by the specific index within square brackets as shown here. Therefore, if you want to access the first value, you call value 0, and if you want to access the second value, you call values 1. Let us look at a few examples. We will consider the same list again. The first step is to create the list. We can do so by writing values is equal to, within square brackets, 15, 20, 96, 32, 17. What do you think will be the output of this print statement? You can pause the video and try to guess the answer. Since the specified index here is 0, it will output the value 15, which is at index 0. Similarly, since the specified index here is 4, it will output the value 17, which is at index 4. You can see that this print statement is different from the previous ones. Instead of having a single index, it has a range of indices. You might think that it will output values from 15 to 32, as 15 is at index 0 and 32 is at index 3. However, it will only output values from 15 to 96. 15 is at index 0 and 96 is at index 2. Similarly, if the specified index range is from 2 to 5, it will output the values from 96 to 17, where 96 is at index 2 and 17 is at index 4. To generalize it, if the specified range of indices is from m to n, the values considered are from indices m to n minus 1. Now, let us look at how to update a list. There are several modifications we can do to a list. Again, we'll be using the same list here as well. The first operation is appending values to a list, which means adding values to the end of the list. Suppose we want to add 60 to the end of this list, as shown in the diagram using the purple colored square. As usual, the first step is to create the list. Next, to append the values, we can use the append method. When you call values.append 60, it will add 60 to the end of the values list. To check whether 60 has been added successfully, we can print the values list and check. When you call print values, it will output the entire content of the values list. You can see that 60 has been added successfully to the end of the list. The next operation is updating the value at a specific index. Let's say we want to update the value at index 2, which is 96 in this example, to 60 as shown in the diagram. The first step, as always, is to create the list. Now, to update the value at index 2, we use the statement values within square brackets 2 is equal to 60. What it implies is update the value at index 2 of the values list to 60. To check the modification, let's print the list. We can see that the value now at index 2 is 60 and not 96. The third operation is removing a value from a list. Suppose we want to delete the value at index 1, which is 20. This diagram illustrates what we want to achieve. First, let's create the list. To remove a value from a list, one method we can use is remove. What it does is, it will remove the value given in the brackets from the list. Since the value at index 1 is 20, we call values.remove20. To check whether the value has been deleted successfully, let's print the list. We can see that 20 no longer exists in the list. If we take a step back and have a closer look at the remove function, we should know the value at a particular index to use the remove function. For example, here, we should know that the value at index 1 is 20 to use the remove function. However, there can be situations where we do not know or do not want to know the value at a particular index. In such situations, we can use another function called delete. When you call delete values within square brackets 1, it will delete the value at index 1 of the values list. So far, we have learned a lot about lists. One of the best ways to learn is to practice. Here is a practice exercise for you to try out. You have been given a code segment, and the question is, what will be the output if you execute it? You might find that the print statement here is different from what we have learned so far. We will learn about this later in this lesson. However, I encourage you to run this code and figure out by yourself how this print statement works. The answer to this question is available on the last slide. But please make sure you try your best before looking at the answer. The next topic we are going to cover is multidimensional lists. So far, we looked at one-dimensional lists where a set of values are stored between square brackets. An important question at this point is, how can we create two-dimensional lists? Before answering that question, we should ask ourselves, do we need two-dimensional lists? Let us take a matrix, which is something we all are familiar with. Earlier, in the library example, we said that we need the second book from the left. But in a matrix, suppose you want to access this 2 in the purple square. You have to specify not only its row-wise location, but also its column-wise location. This means now we are dealing with 2 dimensions. How can we store this data in a list? The easiest solution is to increase the dimension of the list to 2 as well. The variable data here holds the values of the matrix in a 2-dimensional list. You can see that there are 3 lists inside another list. Each internal list here holds the value of a row in the matrix. For example, the first internal list contains the values 1, 1, 1, which is the first row in the matrix. Now the question is, how to access the values in a 2-dimensional list? The answer is simple. It is the same way as accessing the values in a matrix. What is the coordinate of the 2 in purple square in this matrix? It is 1, 1 because it is in the second row and is in the second column. Therefore, if we want to access this 2, we call data 1, 1 because first, you have to find the internal list at index 1 and inside the list, you have to get the value at index 1 again. Similar to what we learned earlier, if we want to update this value, we call data 1, 1 is equal to 25. If you print the updated list, you can see that the value has been changed from 2 to 25. We can also do other operations such as append. What does this line of code do? We are instructing the program to find the internal list at index 1 and append 2 to it. If we print the list again, you can see that the value 2 has been added to the internal list at index 1. Now, let us look at some more list operations. The first one is to find the length or size of a list. The function we use here is len, which stands for length. The length of this list is 3, as the list contains 3 values. The next operation is concatenation. Suppose we have 2 lists A and B. If we want to combine the contents of the lists A and B, we can achieve it by using the plus operator. A plus B will output a single list with contents from lists A and B. You can see in the output that the values 1, 2, and 3 are from list A, and the values 4, 5, and 6 are from list B. The third operation we are going to look at is repetition. Looking at an example will make it easier to understand how repetition works. The list here contains the string hi. If you multiply this list by 4, the content within the list will be multiplied 4 times, as shown in the output. Note that we are not getting 4 separate lists, but 1. The next operation is membership. The idea is to check whether a value is available in the list. In the given example, you can see that we are using the in operator to check membership. The statement 3 in list 1, 2, 3 checks whether the value 3 is available in the list. Since the value is available, it returns true. If the value is not available, it will return false. The final operation we are going to discuss is iteration. Iteration means going through the list one element at a time. The code says, for x in list 1, 2, 3, print x. How it works is, the first element in the list, which is 1 in this example, will be assigned to the variable x. Then the print statement will be executed. After that, the second value in the list, which is 2, will be assigned to the variable x. The print statement will be executed again. This pattern continues until the last element in the list. It might be a little confusing at this point, but do not worry, you will learn a lot about iteration in the next lesson. We have come to the last part of this lesson, which is indexing and slicing. Let us use an example to learn these concepts. Consider the given list, which contains 3 strings, A, B, and C. We have already learned about indices at the beginning of this lesson. We need them to access the values in a list. When we call print L within square brackets 2, it will print the value at index 2, which is C. There is an alternative way of indexing called negative indices. In negative indexing, the last value of the list is indexed -1, similar to how the first value is indexed 0 in normal indexing. The rest of the elements are indexed from right to left. If you consider the given example, you can see that the last element C is indexed -1, then we move to the left, B is indexed -2, and A is indexed -3. Therefore, when you call print L within square brackets -2, it will output B. Slicing means extracting a part of the list. We have learned about this earlier as well, but without using the term slicing. If you remember, we said, if we use the range m to n within square brackets, it will consider the values from index m to index n-1. However, the print statement here is something which we did not learn earlier, but was used in practice exercise 1. When you say L within square brackets 1:, leaving the second part of the range empty, it means from index 1 up to the last value of the list. Hence, in this example, it outputs the values B and C. Here is an exercise for you to practice what you have learned. The question is, you have been given a list of numbers and you have to write a program to output all the even numbers in the list. There should not be any duplicates, which means if there are two 4s, you have to output it only once. The answers to practice exercises 1 and 2 are available on the last slide of the presentation. We have reached the end of this lesson on lists. In the next lesson, you will learn about iterations in detail. Thank you.
Hello and welcome to this lesson on sets in Python. My name is Buddhika Karnaratna and I'm from the University of Morato. This is part of the course Python program. This is the standard color coding for the presentation slides. I'm sure you are quite familiar with this standard now. Let's first try to understand what is a set in Python. A set in Python is a type of data structure that can hold unordered elements. All elements in a set are unique and an element can be of any data type. Unlike in lists, the elements in a set are not indexed. Therefore, you cannot perform indexing operations on sets. We will now move on to discuss when do we need to use sets in Python. We can use sets as a collection in Python when the order of the elements does not matter. However, keeping unique elements is important. As we mentioned in the previous slide, these are notable characteristics of sets in Python. We can create sets in Python either using curly braces or set constructor. The first example shows the usage of curly braces to define a set called fruits, which has 3 unique elements. In the same example, the same set is created using what we call the set constructor. Later, you may try these examples on the Python playground provided in the lecture note. In this section, we will look into some important set operations, starting with finding the length of a set and accessing elements. We will move on to see how to add and remove elements. Thereafter, we will look at some of the familiar mathematical operations related to sets, such as union, intersection, and difference. You have probably studied about these basic mathematical set operations at school. Please take a little bit of time to revise and refresh your memory about those concepts. The length of a set is the number of elements included in the set. We can find the length of a set using the len function, L-E-N function. We should pass the name of the set as the parameter to this function. The len function will return an integer value equal to the number of elements included in the set. In the example shown here, the output is 3, as the set fruits has 3 elements. Let's now see how to access elements of a set. As already mentioned before, a set is an unindexed collection. Therefore, we cannot use indexes to access elements, like in lists. However, we can loop through the elements of a set. You will actually notice that the items are printed in no specific order. If you run this code multiple times, each time you will get a different order. That is because the elements in the set are unordered. You can either use add method or the update method to add elements to a set. The add method allows to add a single element to a set, while the update method allows to add multiple elements to a set. Notice how the element mango has been added to the set fruits using the add method. It would be interesting to see what happens if we try to add an already existing element to the set. I will leave that for you to try out. As you can see in the second example, we can use the update method to add more than one elements to the set at the same time. Now, let's see how we can remove elements from a set. We have several ways to do that. We can use the remove method, which takes in the element as the parameter. However, if we provide an element which is not present in the set, the method remove will raise an error. Comparatively, a discard method does not complain even if the given element is not present in the set. Notice the difference. On the other hand, the method pop removes a random element from the set. I strongly recommend you to play with these examples in the Trinket playground provided in the lecture note. That is how you will learn these concepts much better. Okay, now we move on to look at some mathematical concepts and how to do those calculations. Starting from the set union, the union of the sets A and B will be a set containing all the values of set A and B, but if there is any common value, the union set will only contain one copy of that common value. In the given example, set A has values 1, 2, 3, 4, and 5. Set B has 1, 3, 5, 7, and 9. We see some common values. They are 1, 3, and 5. Therefore, the union set of sets A and B contain the elements 1, 2, 3, 4, 5, 7, and 9. So how do we get the union? We can either use the vertical bar, or in other words, the pipe symbol, or the method union to get the union of sets. Please refer to the examples provided and please try out those examples. Now we move on to set intersection. Intersection of sets results in a new set comprising only of the common elements of the given sets. In this case, A and B, in our example, 1, 3, and 5 are the common elements of sets A and B. So how do we get this set intersection in Python? We can either use the symbol AND, or there's a method called intersection to get the intersection of two or more sets. Once again, please play with these examples by your own in the Trinket playground. That will be provided in the lecture note. Now, finally, we move on to look at set difference. So what does set difference results in? It results in a set comprising of all the elements that are present in one set, but excluding the common elements. For example, A difference B produces a set containing 2 and 4. So how do we get set difference in Python? We can either use the symbol minus or the method difference to obtain the difference of two sets. You have more examples to follow in this section as well. And with that, we come into the end of this lesson on sets in Python. I hope you have had a basic understanding to the concept of sets in Python. Please practice your examples and we will see you in another lesson. Thank you. Hello and welcome to this lesson on dictionaries in Python. My name is Buddhika Karunaratne and I am from the University of Moratuwa. This is part of the course Python program. This is the standard color coding for all the presentations in this series of lectures. You should be now familiar with this color code. So, what is a dictionary in Python? By this time, I'm sure that you're familiar with collections like lists and sets in Python, which were covered in previous lessons. A dictionary is another type of collection available in the Python programming language. However, a dictionary has some notable features that makes it unique. A Python dictionary used to be an unordered collection. However, since Python version 3.7, a dictionary is an ordered collection, which means it keeps track of the order that the elements were added. A Python dictionary is also mutable, which means the values can be changed. The elements in a dictionary are stored as key value pairs. Thus, the elements can be indexed based on the keys which are distinct. Furthermore, duplicate keys are not allowed in a dictionary. So, when should we use a dictionary in programming in Python? Essentially, when the data we want to store has a unique reference that can be associated with the value. The key value structure, it allows us to store such samples conveniently using a dictionary. Notice that no other type of collection allows that kind of behavior in Python. So that is why a dictionary is quite important. Furthermore, if we would like to access an item inside the collection instantly, storing them in a dictionary is preferred because it allows instant actions without having to go through the whole collection of data. Now, let us do a quick comparison of dictionary versus a list in Python. Items in a dictionary are accessed using keys, whereas items in a list are accessed using index. So indexing a list, you are familiar by now. A list is basically a collection of elements, and a dictionary has key value pairs as elements. That is a major difference between a list and a dictionary. Also, a list allows duplicate elements, whereas dictionary does not allow that behavior. And this would be a good time to refresh your memory on Python lists in order to do a better comparison with dictionaries. So now let's see how we can implement and use a dictionary in Python. So in the first bit of code you see, we are initializing an empty dictionary. The name of the dictionary is my first date. So in the second example, we are defining a dictionary called scores. And we have added the key value pairs within curly brackets. We have 3 key value pairs here. In other words, we have 3 elements in this dictionary. The key and the value in each element is separated by a colon. In the first element, the key is summon and the value is 75. Now, how do we access values in a dictionary? One way is to provide the key within square brackets. In that way, it will return the corresponding value, the value corresponding to that given key. There's another way. That way is to use the function get and pass the key as the parameter. In this example, you can see the both ways and you can try out both ways if you follow this example. Now, let's go through some of the important operations related to dictionaries. First of all, we can add an element to an existing dictionary by specifying the new key within square brackets and assigning the corresponding value. In the example at the bottom, we are adding a new key value pair in which the key is Sunil and the value is 60. We can actually update existing values in a similar way as you can see in the second example. There, we update the value corresponding to the key summon to 70. Notice how we can update the values inside the dictionary. Now let's look at removing items. So to remove an element from a dictionary, we can use the pop method. This method takes a key as the parameter, and when invoked, it will remove the element corresponding to that key. In the example given, we pass Nimal as the parameter, and the element related to that key is deleted from the dictionary. If we want to remove all the elements in the dictionary, we can use another method which is called clear. So if you use the clear method, it will delete all the elements inside the dictionary. As you can see in the second example, we use the clear method to delete all the elements and it returns an empty dictionary. Now, we can get all the keys in a dictionary by calling the function keys. So in the second line of the first example, this method is called and the keys are obtained into a list. Similarly, we can get all the values in a dictionary by calling the function values. And it is shown in the second example. Now, this is another important thing. We can iterate through all the elements in a dictionary using a for loop. Notice how this for loop gets all the keys in the dictionary and iterates through the dictionary to print the key alongside the corresponding value. This is actually quite a useful operation when we use dictionaries in Python programming. Now let's look at an example how we can use dictionaries to solve a simple problem. In this problem, you are given a list of names with possible duplicate entries. The requirement is to determine the unique names and the number of times each name appears in the list. Right, now we will see how to do this. The whole program is given in this slide for your reference. Let's carefully go through it and try to understand step by step. So what we have first is all the names put inside the list. That list is called names. Then we have to create an empty dictionary and call that counts. So in this example, we are calling that empty dictionary counts, and we will be using that dictionary later on. Then what we do, we iterate through the list of names using a for loop. It's quite a familiar and commonly used operation. So in this for loop, at each iteration, we check whether the current name is already included in the dictionary as a key. So that's what is done in the if condition. So if it is not included, we add a new element to the dictionary with the current name as key and 1 as the value. So that's one occurrence of a name that we have not seen so far, that the dictionary does not include so far. Otherwise, or else, that means the current name is already included in the dictionary as a key. Then what we do, we increment the corresponding value by 1. So basically we are counting, we are doing a counting here. And we keep doing this until we go through all the elements in the names list. And finally, we print the contents of the dictionary counts. When you do that, you will see the unique names and the number of times they appeared in the given list. Now, please attempt this example by yourself. It is very important. So far, we have seen all the advantages and capabilities of Python dictionaries, but they are not suitable for all purposes. For example, if it is a requirement that the data you store should not be changed, dictionary might not be the best option, because as we know, as we have introduced at the very beginning, the dictionaries are mutable and the values inside dictionaries can be changed without a problem. Apart from that, if the memory usage of the program or the application is a concern and it is limited, you might need to minimize the use of dictionaries as they consume more memory compared to other type of collections. So you have to be careful about these points when you use dictionaries. That brings us to the end of the lesson on Python dictionaries. I hope you have learned the basics and got an understanding about how to use dictionaries in Python programming. Thank you.
Hello everyone, welcome to the lesson on tuples, which is part of the course Python Programming. In this lesson, we will discuss the fundamentals of tuple data structure and explore how they are different from the list data structure which we learned earlier in the course Python for Beginners. If you have not followed the lesson on lists, I highly recommend following it before this lesson, since it will help you understand the content better. This is the color coding we'll be using throughout this lesson. This lesson is structured as follows. We will start the lesson with an introduction to sequence data types and tuples. Next, we will discuss how to create tuples and access values in them. After that, we will briefly look at tuple packing and unpacking. Then, we will talk about insertion, deletion, and update. We will also compare tuples and lists. Finally, we will look at some tuple operations and conclude with a summary. Further, throughout this lesson, we will look at several examples and exercises that will help you understand the content better. Let us start with an introduction to sequence data types. What are sequences? A sequence is an ordered collection of elements. We call them ordered because the elements will be maintained in a specific order and the order will not change. Consider the following example. we have a variable with the string computer. Then we create a list with these letters. When we print the list, we can see that the list keeps the elements in the same order as the input. Next, we create a set, which is another data type in Python with these same letters. When we print the set, you can see that the letters are in a completely different order. Therefore, we categorize list as an ordered data type and set as an unordered data type. Three basic sequence data types in Python are list, tuple, and range. In our first course, Python for Beginners, we learned about the list data structure. In this lesson, we will discuss the tuple data structure, which is very similar to lists. The first topic we are going to cover is the structure of tuples. Tuples contain comma-separated values between round brackets or parentheses. The only difference from lists is that the square brackets in lists are replaced by parentheses. This is a sample tuple in Python. You can see that the values are comma-separated and are within parentheses. Even though we say that tuples contain values within parentheses, parentheses are not mandatory when creating a tuple. We'll see an example in the next slide, which will illustrate this idea clearly. Similar to lists, the values within a tuple need not be of the same data type. Now, let us look at a few examples to understand what we discussed in the previous slide. In this line of code, we are creating a tuple with 4 elements. It is important to note that the first 2 elements A and B are strings, 20 is an integer, and 4.1 is a floating point number, which are all different data types. You can check the data type of a variable using the type function. If we call type with tuple 1 as the input parameter, you can see that it outputs tuple as the data type. In the previous slide, we mentioned that it is not mandatory to have the parentheses when creating tuples. Here, we have another variable named tuple2, which contains the same set of elements as tuple 1, but without the parentheses. If we print tuple2, you can see that the system has added the parentheses by itself. If we check the data type of tuple2, it is indeed a tuple. A tuple with a single element is a special case. Let us see why. The variable tuple3 contains one element, which is string A, inside parentheses. If we check the data type, it turns out to be a string and not a tuple. So, how do we create a tuple with a single element? We should include a comma after the element as shown here. If you check the data type of the variable tuple4, you can see that it is a tuple and not a string. Now that we know how to create tuples, let us look at how to access values in a tuple. Accessing values in a tuple is similar to lists. Consider this tuple that contains 5 elements, 15, 20, 96, 32, and 17. The first step is to create the tuple. We code myTuple is equal to, within parentheses, 15, 20, 96, 32, 17. The parentheses are optional. Similar to lists, tuples are also indexed starting from 0. Hence, when we call myTuple within square bracket 0, it will output the first element in the tuple, which is 15. Similarly, if we want to access 17, which is at index 4, we call myTuple within square brackets 4. You can see that we get the expected output, which is 17. The next subtopic is accessing values using negative indices. This also works similar to lists. We have learned in course 1 that in negative indexing, the last element is indexed -1, and the values are indexed from right to left as shown in the diagram. Let us look at a sample code. As always, we create the tuple first. Then, when we call myTuple within square brackets -1, we get the last element 17 as the output. Similarly, using -3, we'll return the element at index -3, which is 96. The next subtopic under accessing values in a tuple is slicing. You are aware at this point that slicing means extracting a part of a sequence, which in this lesson is a tuple. Slicing is exactly the same as what we learned in the lesson on lists. Let us consider the same tuple here as well. First, we create the tuple. What will happen when we call myTuple with the range 0 to 3? It will output the values from index 0 to index 2. Remember, if the range is from m to n, the values considered will be from index m to n-1. Therefore, the output will contain 15, 20, and 96. Similarly, if the range is from 2 to 4, the values at indices 2 and 3 will be outputted. The final subtopic under accessing values is nested tuples. Nested tuples are similar to nested lists. Let us create a nested tuple first. This variable contains two tuples inside another tuple as shown here. The first inner tuple contains the values 1 and 2, while the second inner tuple contains the values a and b. Suppose we want to access the value 2. First, we need to access the inner tuple at index 0, and inside that inner tuple, 2 is located at index 1. Hence, we call myTuple within square brackets 0 and 1, where the 0 points to the inner tuple at index 0, and 1 points to the element at index 1 inside that inner tuple. Similarly, if we want to access the inner tuple that contains the values a and b, we know that it is located at index 1. Hence, calling myTuple within square brackets 1 will output the entire tuple at index 1 as shown here. The next topic we are going to discuss is tuple unpacking. Before that, what is tuple packing? Tuple packing is nothing but assigning values into a tuple. In this example, we are assigning the values car, pen, and ice into a tuple. This is called tuple packing. Tuple unpacking is extracting the content of a tuple into variables. Let us look at an example to understand what it means. We have three variables, a, b, and c, on the left-hand side of the equal sign, and the tuple myTuple on the right-hand side. We know that the tuple on the right-hand side contains the values car, pen, and ice. What this line of code does is, the content of the tuple will be assigned to the variables on the left-hand side. Hence, the string car will be assigned to variable a, the string pen will be assigned to variable b, and the string ice will be assigned to the variable c. To confirm, let us print the variable b. You can see that it outputs the string pen as expected. One condition when using tuple unpacking is the number of variables on the left-hand side should be equal to the number of elements in the tuple. In our previous example, myTuple contains 3 elements. Hence, we have 3 variables on the left-hand side. Here is an exercise for you to try out. Run the following code and analyze the output. If you get an error message, do not worry, because you are supposed to get an error message. So far, we have discussed how to create tuples and how to access values in tuples. Let us move on to insertion, deletion, and update in tuples. Let me give you a quick exercise. Pause the video and run the following code. See what happens. You ended up with an error message, right? What does the error message say? Type error, tuple object does not support item assignment. Why are we getting this error? What does this error message mean? This is what we are going to discuss in the next slide. You got this error because tuples are immutable. What does it mean? It means once a tuple is created, it cannot be modified. Hence, a tuple does not support insert, delete, and update operations. Unlike tuples, lists are mutable. We learned in course 1 that we can insert, delete, and update values in a list. Let's compare lists and tuples. By now, we know that they are very similar to each other. However, lists are more versatile than tuples. You can update the values in a list and expand or shrink it, but you cannot do any of those with a tuple. On top of that, lists have more built-in functions than tuples. Most of you will be wondering, aren't tuples useless since lists have all these advantages over tuples? It is indeed a good question. We are going to discuss this question in the next few slides. Tuples do have a significant advantage over lists. Tuples are memory efficient than lists, which means they consume less memory. Let us look at an example to check whether it is true. Let us create a tuple and a list that contain the same set of elements. Now, let us measure the amount of memory consumed by each of them. We will use a Python function called getSizeOf. It will return the amount of memory consumed in bytes. To use this function, we need the sys module. This line of code will import the sys module that we need. Now, if we run sys.getSizeOf mylist, we get the output 104, which means our list has consumed 104 bytes of memory. Let us do the same for our tuple as well. We can see that it has consumed only 88 bytes of memory, which is 15% less compared to our list. But why? Why do tuples consume less memory? We will not be discussing the answer to this question here, since it is an advanced topic to discuss at this point. However, if you are interested, follow the link provided under Supplement 1, which is available on the last slide. It explains clearly why tuples consume less memory compared to lists. When do we use tuples over lists? If the data need not to be changed in the future, use tuples since it will save a significant amount of memory. If the data needs to be modified in the future, use lists since tuples are immutable. This is the final section of this lesson where we will discuss some tuple operations. We looked at the same set of operations when we were discussing lists as well. The first operation is length, which returns the length of the given tuple. Here, we are calling the length function with a tuple that contains the values 1, 2, and 3 as the input parameter. Since the tuple contains 3 elements, the function returns 3. The second operation is concatenation, which means joining together. Suppose you have 2 tuples A and B. If you want to combine the contents together, we can achieve it using the plus operator. A plus B will output a single tuple with contents from tuples A and B. You can see in the output that the values 1, 2, and 3 are from tuple A, and the values 4, 5, and 6 are from tuple B. The third operation we are going to look at is repetition. Looking at an example will make it easier to understand how repetition works. The tuple here contains the string hi. If you multiply this tuple by 4, the contents within the tuple will be multiplied 4 times as shown here. Note that we are not getting 4 separate tuples, but 1. The next operation is membership. The idea is to check whether a value is available in a tuple. In the given example, you can see that we are using the in operator to check for membership. Statement 3 in the tuple that contains the values 1, 2, and 3 checks whether value 3 is available in the tuple. Since the value is available, it returns true. If the value is not available, it will return false. The final operation that we are going to discuss is iteration. Iteration means going through each element in the tuple one after the other. The code says, for x in tuple that contains the values 1, 2, and 3, print x. How it works is, the first element in the tuple, which is 1 in this example, will be assigned to the variable x. Then the printx statement will be executed. After that, the second value in the tuple, which is 2, will be assigned to the variable. The printx statement will be executed again. This pattern continues until the last element in the tuple. Let us quickly summarize what we have learned in this lesson. Tuple is a sequence data type, which means it is ordered. Tuples and lists are similar to each other in many aspects. For example, in their structure and how the values are accessed. Tuples are immutable, which means they cannot be modified after creating them. Tuples are memory efficient compared to lists. Finally, tuples contain many useful built-in functions. We have reached the end of this lesson. I hope you enjoyed learning about tuples. Hello everyone. Welcome to the lesson, Lists as Stacks and Queues, which is part of the course Python Programming. In this lesson, we will introduce the queue and stack data structures and discuss how to build them using lists. This is the color coding we will be using throughout this lesson. Let us start with a brief introduction to stacks and queues. Stacks and queues are widely used elementary data structures. We call them elementary because they are straightforward and there is nothing complicated about them. One important property of stacks and queues is that their insert and delete operations are pre-specified. This means you cannot change how insert and delete operations are carried out. Are you interested in learning how they are carried out? That is what we are going to discuss throughout this lesson. In our first course, Python for Beginners, we learned about lists in detail. In this lesson, we will discuss how to use lists as stacks and queues. The first data structure we are going to look at is stacks. One of the easiest ways to understand stacks is by looking at an example from our daily lives. Consider a scenario where you have some boxes and you have to place them on top of each other. You get your first box and place it on the floor. You get the second box and place it on top of the first one. Finally, you get the third box and place it on top of the second one. Now, we have a stack of 3 boxes. Then, a friend of yours comes and asks you to hand over the boxes to him or her. How do you remove the boxes? The first box you remove is the third one, which you have placed last. Then, the second one. You cannot remove the first box at the bottom without removing the boxes on top. Now, how is this example relevant to stacks? Placing the boxes on top of each other is similar to insert operation in stacks, and removing the boxes is similar to delete operation in stacks. Let us list down the properties of stack data structure from our box scenario. First, when you place boxes on top of each other, it creates a linear structure. There are no branches. Similarly, stacks are also linear structures. Second, the box you placed last is removed first. Last in, first out. Similarly, in stacks, the element you inserted last is deleted first. Third, how you place and remove boxes is fixed. You can only place boxes on top of each other and remove boxes from the top. You cannot insert or remove boxes at random locations. Likewise, in stacks, you cannot insert and delete elements at random locations. You can only insert and delete elements at the end of the stack. Now that we know the fundamentals of a stack, let us look at an actual stack with some values. We are going to insert the following 4 numbers, 17, 8, 13, and 5 into a stack. First, we insert 17. In stacks, we need to keep track of the last element inserted. Why? Because when we delete the last element inserted, and when we insert to the end of the stack. Now that we know why we need to keep track of the last element, the next question we have to ask is, how do we achieve it? It's simple. We keep a pointer to the last element. In this example, the pointer named top is performing the task. Next, we insert 18 and the pointer top is shifted from 17 to 8. Then we insert 13 and finally we insert 5. In the context of stacks, we use the term push for insert and pop for delete as shown in the diagram. So far, we have learned about the properties of a stack. Now, it's time to look at how to implement a stack using a list. Pause the video and think for a moment. What are the requirements to implement a stack using a list? First, we need a list. Second, we need a pointer for the last element. And finally, we need the push and pop functions. We have our list of requirements now. Let's move on and discuss how to implement a stack using lists in Python. First, let us create an empty list that is going to be our stack. I have named my list my stack. The next step is implementing the push and pop functions. The push function should be able to insert a given element to the end of the stack. In the implementation given here, the function takes a stack and the new value to be inserted as inputs. The append method available to lists is used to insert the value at the end of the stack. The pop function should remove the last element inserted. In the implementation given here, the function takes a stack as input. The pop method, which is a built-in method available to lists, is used to remove the last element of the list. The removed value is returned by the function. Since the list data structure has a built-in method to remove the last element, we do not need a pointer to keep track of it. Now, let's insert a few elements into the stack that we have created. To insert A, we call the push function with myStack and A as input parameters. It will insert A at index 0 of the list. Next, we call the push function with B as the input parameter. It will insert B at index 1. Similarly, we insert C at index 2 of the list. To confirm our insertions, we can simply print the stack. You can see that the elements have been inserted correctly. Now that the insertions are complete, let us move on to deletion. To delete a value from our stack, we call the pop function we implemented with myStack as the input parameter. As shown here, it returns C, which is the last element we inserted. When we call pop again, it returns B at index 1, and finally, the pop function will return A at index 0, leaving us with an empty stack. I believe you are clear at this point how to implement the stack using the list data structure in Python. Before moving on to our discussion on queues, let us look at an application of stacks. One of the simplest examples is the undo function. Suppose you want to draw a triangle. This is the stack we will be using to keep track of the changes. You draw the first line, which is the first change you make. Then you draw the second line, which is the second change. And finally, when you try to draw the third and last line, you make a mistake. You can correct it by using the undo function, which will remove the last change you made. It is similar to the pop operation in a stack. Now, you can redraw the last line correctly. This example clearly illustrates how useful stacks are. The second data structure we are going to discuss in this lesson is queues. Let's start our introduction to queues by looking at a real-world example. Assume a scenario at a bank where people are coming to deposit money. People form a queue in the order in which they come in. The person who comes first stays at the front of the queue. The person who comes in second stays behind the first person. Similarly, the person who comes in third stays behind the second person. Now we have a queue with 3 people. I believe you all are familiar with how queues work in real life. The first person in the queue who entered the queue first deposits the money and leaves. Then the remaining people in the queue move 1 position forward. Now the person who entered the queue second deposits the money and leaves. This pattern continues until the last person. The queue data structure also works in a similar fashion. Let us identify the properties of a queue from the previous example. First, the queue is linear. It does not have any branches. There is only one line. Second, the person who enters first leaves first. First in, first out. Third, how people join and leave the queue is fixed. One can only join at the end of the queue, and only the person at the front gets the chance to take care of business and leave. One cannot come and join at random locations or takes care of business and leave without being at the front. Now that we know the fundamentals of a queue, let us move on to building an actual queue containing some values. We are going to insert the following 4 numbers, 17, 8, 13, and 5, into a queue. First, we insert 17. As shown here, a queue has a head and a tail. Insertion takes place at the tail of the queue, and deletion happens at the head of the queue. Next, we insert 8, 13, and finally 5. After inserting all the 4 numbers, this is what our queue looks like. In the context of queues, we use the term enqueue for insert and dequeue for delete. Enqueue operation adds an element to the tail of the queue, and dequeue operation removes an element from the head of the queue. So far, we have learned about the properties of a queue. Now, let us look at how to implement a queue using a list. Pause the video and think for a moment. What are the requirements to implement a queue using a list? First, we need a list. Second, we need the pointers to the head and tail of the queue. And finally, we need the enqueue and dequeue functions. We have our list of requirements now. Let us move on and discuss how to implement a queue in Python. First, we create an empty list which is going to be our queue. I have named my list my queue. Then, we implement the enqueue and dequeue functions. The enqueue function should append the given value to the tail of the queue. In our implementation here, the enqueue function takes the queue and the new value to be inserted as input parameters. The append method, which is available for list data structure, is used to insert the value at the tail of the queue. The dequeue function should remove the first element. In our implementation here, the function takes the queue as input parameter. The pop built-in method is used to remove the first element. The pop method should be called with parameter 0 to specify index 0. The removed value is returned by the function. Since Python has built-in methods to remove from the head and append to the tail, we do not need separate pointers to the head and tail of the queue. Now, let's insert a few elements into the queue that we have created. To insert A, we call the enqueue function with myQueue and A as input parameters. It will insert A at index 0 of the list. Next, we call the enqueue function with B as the input parameter. B will be inserted at index 1 of the list. Similarly, we insert C at index 2 of the list. To confirm our insertions, we can simply print the queue. You can see that the values have been inserted correctly. Now that the insertions are complete, let us move on to deletion. To delete a value from our queue, we call the dequeue function we implemented with myQueue as the input parameter. As shown here, it returns A, which is the first element we inserted. When we call dequeue again, it returns B, which is the second element we inserted. I believe you are clear at this point how to implement a queue using the list data structure in Python. Let us look at an application of queues, which is file reading in computers. Consider a scenario where we have several files stored in a disk. There are 3 programs running in parallel, and they need to access multiple files. However, our hard disk can read only one file at a time. Hence, what it does is, it keeps a queue where all the incoming requests are stored. In this example, program P2 has made the first request to read a file. P1 has made the second request, and P3 has made the third one. Using a queue ensures that the program which makes the request first will receive the file first, which ensures fairness. This example clearly illustrates how useful queues are. We have reached the end of this lesson. I hope you enjoyed learning about how to use lists as tags and queues. Thank you.